Welcome to a Mid-American Energy coal-fueled power plant. This plant converts the energy within coal into electricity. The plant's supercritical technology allows boiler and turbine equipment to operate at extremely high temperatures and pressures, requiring less coal and resulting in fewer emissions for the same electrical output. Most coal was formed hundreds of millions of years ago, when much of the earth was covered by steamy swamps. As plants and trees died, their remains sank to the bottom of the swampy areas, accumulating layer upon layer. Eventually, a dense, spongy material called peat formed. The Earth's surface gradually changed. Seas and great rivers deposited sand, clay, and other minerals on top of the peat. These deposits formed sandstone and other sedimentary rocks, and buried the peat beneath the Earth's surface. Their weight squeezed water from the peat. Over millions of years, continued heat and pressure gradually changed the peat and sediment into coal. There are two common ways to mine coal from the ground. The first method is used when coal lies close to the surface. With surface mining, topsoil and layers of rock are removed to expose the coal. The second method is underground mining, sometimes called deep mining. This method is used when coal is located several hundred feet below the Earth's surface. Underground mines can be up to 1,000 feet below ground and require elevators to transport workers to the bottom of the mine. Once the coal is removed from the earth, it typically travels by conveyor belt to a preparation plant located at the mining site. There, it's cleaned and processed to remove unwanted materials such as dirt and rock. After the coal has been processed, it's shipped to market. Most coal in the United States is transported by train. However, coal also can be shipped by barge, ship, or truck. The coal arrives at the power plant and is unloaded into a storage area. When needed, it's moved by conveyor belt from the storage area to bunkers in the plant. Bunkers typically hold enough coal to fuel the power plant for approximately half a day. From the bunkers, the coal is fed into mills that pulverize it into a very fine powder. The pulverized coal is mixed with hot air and blown into the boiler. Inside the boiler, burners ignite the coal and air mixture to achieve complete combustion and create the maximum amount of heat possible. Coal combustion residue called bottom ash collects in the bottom of the boiler. This ash can be sent to a landfill, but is often sold as material for roadway construction. The intense boiler heat turns water in tubes into steam that can reach up to 1,100 degrees Fahrenheit. Heating the water also causes it to expand and increases the pressure in the pipes up to 3,700 pounds per square inch. The steam passes through 4 turbines before it is turned back into water and used again. The steam first is piped to a high-pressure turbine and then is returned to the boiler to be reheated. It then is piped to an intermediate pressure turbine and finally to 2 low-pressure turbines. The steam blasts into each turbine, turning blades that are attached to a single shaft. The turning shaft continues into the adjacent electrical generator. As the shaft rotates, it turns electromagnets within a series of wire coils to produce electricity. The electricity from the generator passes through a step-up transformer where its voltage is increased. It then travels through the power lines that carry it to homes and businesses. The water that is heated into steam at coal-fueled power plants is called feed water. This water typically is supplied by wells and passes through a cleaning system to remove minerals and other impurities. After the feed water converts into steam and moves through the low-pressure turbine blades, it passes across tubes within the condenser that turn it back into water. These tubes contain cooler water from a separate circulating water supply. The circulating water constantly flows between the condenser and an external cooling tower. Fans and exposure to the air within the tower lower the temperature of the circulating water before it returns to the condenser. Hot exhaust gases from the burning coal-air mixture contain regulated emissions such as nitrogen oxides, sulfur dioxide, mercury, and particles of ash. Before the gases are released into the atmosphere, they go through several processes to remove these materials. The exhaust gases first pass through a selective catalytic reduction unit, or SCR, to break down the nitrogen oxides. The SCR contains modules with many plates coated with a chemical forming a catalyst. To begin the chemical reduction process, ammonia is injected into the gases. As the ammonia and nitrogen oxides pass through the plates, a chemical reaction breaks them down into nitrogen and water vapor. Next, the gases pass through an activated carbon injection system to reduce the mercury content. The injection system sprays activated carbon into the gas stream. Mercury in the gases reacts with the activated carbon to form particles that are removed later in the process. The gases continue on to the spray dryer absorber, or SDA. As they enter the SDA, the gases are sprayed again, this time with a lime and water mixture that reacts with the sulfur dioxide to form particles that are collected downstream. The remaining particles are collected in the baghouse, an area containing large fabric filters. The baghouse acts like a giant vacuum cleaner to remove carbon, SDA dry product, and ash from the exhaust gases. The dry product collected here and in the SDA periodically is removed and taken to a landfill. After the gases pass through the baghouse, they are dispersed into the atmosphere through a tall stack. In the stack, a continuous emissions monitoring system analyzes the gases for sulfur dioxide, nitrogen oxides, carbon dioxide, and carbon monoxide. If the gases are above permitted levels, the monitoring system triggers an alarm in the control room so an operator can take action to correct the problem.